This diagram shows two identical pieces of text reacting to the exact same audio beat. On the right, the movement feels dead, but on the left, the typography feels violently physical, as if it has actual weight. Both words complete their animation in the exact same number of frames, but the left version simulates the momentum and mass of a real-world object. In a strictly 2D vector environment like Adobe After Effects, text layers are just pixels. They do not possess inherent physical mass, gravity, or friction. A common mistake is relying on default linear keyframes or basic software shortcuts like Easy Ease to move those pixels. Those defaults move objects at mathematical constants that fail to simulate real-world physics. Professional momentum is created by engineering the illusion of physics manually. This involves manipulating temporal easing curves to mirror the acoustic amplitude of your audio track. The primary tool for this level of control is the After Effects Speed Graph Editor. Instead of just defining where an object moves on screen, the speed graph allows you to manipulate the concentration of time across that movement, deciding exactly how long it spends accelerating or decelerating. True motion design is not about defining where an object goes. It is about precisely engineering how that object accelerates and decelerates to force the brain to perceive physical weight. Before you can calculate visual momentum, you need a precise temporal target to hit. The setup begins by importing a high-fidelity, uncompressed audio track into your composition. This diagram shows a stylized representation of the After Effects timeline. By tapping L twice, you reveal the track's waveform, which provides a visual map of the song's sonic landscape. Inside that waveform, you look for sudden, dense spikes in the data. These are your transient hits, usually heavy kick drums or sharp snares. You scrub through these clusters to locate the exact microsecond a new vocal onset begins. Playing back the composition, you tap the asterisk key on exact transient hits to drop visual markers directly onto those peaks. The timeline now functions like a musical conductor's sheet music. Every visual action is anchored to a specific sonic event. Without this rigid structural map, applying advanced velocity math is useless. The marked timeline dictates exactly when an action must happen, giving the speed graph a precise target to hit. When a vocalist delivers a sharp staccato beat, the typography requires an aggressive entry to match. Linear interpolation fails to translate the raw energy of a sharp sound. Moving text at a constant mathematical speed feels robotic. It breaks the illusion that the pixels are actually reacting to the pressure of the audio. The After Effects speed graph shows a flat, linear line between two keyframes. To change this, we use Bezier handles. For a staccato move, the starting keyframe's outcoming velocity influence is set to 85%. This forces the text to hit maximum speed in a fraction of a second. The second half of the formula targets the end keyframe. Its incoming velocity influence is pulled down to 30%. This creates a steep drop-off in the graph, forcing a rapid deceleration that locks the element into the viewer's focal point instantly. This specific combination of a massive initial burst followed by a sudden stop mirrors the acoustic amplitude of a raw vocal track. The 85-30 curve serves as a high-velocity baseline for translating sharp acoustic energy into a visual perception of mass. We call this the snap-in. Not all audio hits hard. Some moments involve long, drawn-out melodic notes or fading transitions. Applying the aggressive 85-30 snap-in curve to a smooth vocal note feels jarring and disconnected from the music. This diagram shows the curve used for those moments, known as the heavy drift. The formula applies a heavy equal 75% influence to both the starting and the ending keyframes. By pulling both ends of the curve out equally, you create a wide, symmetrical bell shape. This forces the typography into a continuous float that avoids sudden stops or starts. Applying heavy equal influence to both ends of the curve simulates atmospheric drift, matching the lingering emotional resonance of a fading note. Calculating physics in the graph editor is only part of the equation. To actually perceive that momentum, the text requires a clean stage. This requires enforcing the rule of reduction, the practice of stripping away digital clutter to emphasize specific typographic movements. A crowded layout dilutes the impact of carefully crafted velocity curves. If everything on screen moves with the same energy, nothing feels heavy. This demonstrates an industrial noir aesthetic applied to the framework. Deep charcoal backgrounds provide a void, allowing massive white serif typography to command attention. You will notice secondary structural elements in the corners, like monospaced timecodes and grid lines. These elements must sit quietly in a lower typographic hierarchy. They remain static or drift slowly, only activating when compelled by a specific musical shift. Maintaining this strict typographic hierarchy forces the eye to process one major movement at a time, preserving the visual impact of the snap-in. By anchoring layouts to audio transients, executing the 85-30 or 75-75 velocity formulas, enforcing the strict rule of reduction, flat text takes on the weight and response of a physical object.